So we have an international room here, which is great. I'll try to be short. This is the last talk today, so I'm not going to keep you for long. And I'll give you my opinion on the problem. So I'm really prepared for your questions and for your for misunderstanding, for concerns, for doubts. But first of all, I would like to start with a few questions. So I had, in the morning, I had a conversation with a few friends of mine here, and they told me that I underestimate the audience. So that I'm giving the material, I'm giving the content, which is so obvious, and that so many people here understand already what I'm saying. So that's why I want to ask a few questions beforehand of you. How many of you, I'll ask a few questions to understand whether we're on the same page or the information I'm going to give you tonight is actually valuable and you've never heard it before. So how many of you, first of all, how many of you have been on my previous talk today? All right. How many of you seen my talk about the same subject on JPoint? Okay, that's great, a few people. How many of you think that static methods in Java and in OOP in general is a bad thing? About 20%, good. What about null? Again, about 20%. What about getters and setters as a pattern? So you think, you really would raise hands now, you think that's a bad thing. All right, that's good. So maybe I'm really making some mistakes. So you are on the same page. But there is some part of the room which do not agree with that. So it's good. I'm gonna try to convince you. And the last question: what do you think about JPA and the Hibernate in general? Who of you don't like that? Who of you think that JPA and Hibernate is not a good thing in Java? All right, good. So we are kind of somewhere. So let's start. That's what I think. That was my first slide. So that's the second one. I'll probably make the mistake on this number, so it's going to be about 10 slides, not 20. So ORM is a perfect anti-pattern. That's what I think, and I'll try to show you why. It's not going to be a lot of Java code, but first of all, do you understand what ORM is in general? ORM is Object-Relational Mapping. So we have a relational database where our information and data is organized in tables. So each table has a name and rows. So these rows, they contain some data, some cells, and then we want to map that somehow to the Java world. In Java, we are in an object-oriented world. In Java, in any OOP language, we manage objects. We don't manage tables, we don't manage rows, we manage objects. So we need to map them somehow in order to make it more convenient for us to work with this data which are in table format in these tables. So if we would not do the ORM, that in that case we would need to just make SQL requests or SQL requests to the database, retrieve the data in some arrays, and then go through these arrays managing this data somehow. It's not really convenient for the OOP programmer. So the OOP, we want to manage objects, we want to call methods, and that's why we need some kind of a mapping between relational database and object-oriented world. That's why the ORM was introduced. But the way it was introduced is very wrong. That's what I want to say. So I'm not saying that the mapping itself is bad. We do need the mapping. We need to manage relational data from the database. We need to manage somehow this MySQL data. But the way we do it right now in Java, the way we do it with JPA, with Hibernate, with active record, with repository patterns, it's wrong. So I'm going to cover more than I covered on JPoint. On JPoint, there was another conference in Moscow about a month ago, and I was talking there about the same subject, but I was mentioning only the ORM in the way JPA and Hibernate do that. And many people told me that, even on the talk, they said that there is another thing which is called active record, for example, which is not the way JPA works. So the active record is better, is actually what you're suggesting, and there is a repository pattern, which is also what you're suggesting, and there is some libraries for that which actually use that. So how about you explain, you tell people that this is exactly what I'm suggesting. But no, I'm not suggesting that. I'm saying that everything we're having right now for the ORM mapping, not everything, but most of the solutions are quite wrong. And I'll show you why. I'll try to prove. So let's see how it works. I have 3 diagrams for you. That's the first one. This is Hibernate in the way I understand how it works. I'm not really an expert in Hibernate, I just know how it works. I had a few projects with it, so I think maybe now it's a little bit, they have something else, but that's what I've had before. That's what I know how it works. We have the book The book is something in a table. There's some table, probably books or book, in the relational database. And we want to change the title of the book. So what do I do in the Hibernate? I say book set title, and I put the object thinking, for example, the new title for the book, and then I say session.update, and I give this book as a parameter. And we have two objects, basically. The first one is the book, where this title is set. Another object is called session, which is a big, huge ORM machine coming from the Hibernate. So I'm asking Hibernate, I'm giving Hibernate my book, and what the Hibernate is doing, they first of all get the title out of the book, then they create the JDBC statement or something, and most probably they use JDBC, and then the JDBC, when we run the statement, when we execute the update, then we basically create the SQL statement and it goes to MySQL. So we have, am I right on this diagram? This is how it works, right? The Hibernate. That's, okay, good. Because on JPoint they said, no, this is not how it works. So I'm a little bit in doubt now. So I think this is how it works. So we have basically two objects. The first one is a storage of information, storage of data. It contains the title. And then the second one is the object which actually works. Is the object which actually gets this storage of data, extracts some piece of data from it, and does the actual work. And this is, I think, is an anti-pattern. And the problem here is that this one is really treated not like an object, but just a bag of data, just a storage of information, nothing else. So the entire logic is placed somewhere in some monster machine, which is responsible for the functionality, which has to belong here. This functionality has to be in the object, not somewhere outside. So we basically split the one feature, one functionality, one object, one thing into two pieces. The one piece on the left just stores the data. It's just a bag of data which contains the piece of data for us. And another one actually does the work. And this is why it's called, in the previous talk, in the JPoint, I called this as an offensive anti-pattern. So we are offending our objects by taking away pieces of the core functionality out of it and leaving just a dumb functionality of basically storing the title in it. Nothing else. So everything that this book is doing is only keeping the title inside. So it's not really doing the actual work, but it's supposed to do that. In object-oriented programming, an object is supposed to do everything which belongs to its functionality. So when we create a title, we create a book, then we call change the title, or print yourself, or give us some information about yourself. Everything has to be done inside the object, and it has to be covered by the object. That's the idea of OOP. That's the idea of encapsulation. So we're supposed to encapsulate that functionality into the object, not put it outside of there. And the ORM, the way it's done in JPA, is actually not only encouraging us, but this is technically how it works. So they make us to have these dumb, simple, stupid containers of data instead of having real objects and programming in OOP. Someone told me that that active record works differently, or the repository pattern, for example. Who knows what repository pattern is? A few. Who knows active record? They are close. They are almost the same. So the active record or repository pattern it looks like that. It looks more or less like that. So we still have a book. It's not really outside in this case because we have a book and we have a base class. So the book in this case inherits the base. So the base is not like a separate object, it's a parent class. So the book inherits from the base, and then the functionality in the base is exposed through, for example, like that. So we want to change the title, so we create some hash map. That's the example I get from somewhere from internet. So this is, and then I call book.update attributes. So this function update attributes, it's implemented in the parent class, in the base class, for example. So in this case, what's the difference between this implementation and the previous one? Here we have two classes. One is just a simple, stupid storage of data. Another one is a smart engine which can manipulate with this data. In this example, we just put this smart engine into the base class. That's it. So still, when we get access to the object, when we access the object and call update attributes, still this call just goes through and gets to the parent class. So still this functionality is not implemented by our object. It's implemented by the inherited class. And we're just basically abusing the idea of inheritance here. So it looks for us that it's more object-oriented because look, now we have just an object book. Now we don't need to change something in the book and then give this book to the session, and then the session will do the work. Now we're like calling the book and then saying the book, update your attributes. And everything looks like everything is done inside the book. But in reality, no. Still all these calls, they go just to another class, to the parent object. And they are implemented over there. So I'm not in control. I don't control that. I'm still quite stupid and empty. There's no functionality inside me. Everything is just inherited. Even though it looks like it's my functionality, but it's basically just inherited from the parent, and that's it. So I don't add anything. It's still an empty rectangle. Everything comes from the parent class. So this is not, this active record or repository pattern is not what I'm suggesting. So these both approaches are offensive, what I'm saying, because they turn the object into they do not pay respect to the object. They're saying, you're too stupid for me, all like you can do for me is just contain the data. The real work will be done by the engine, by the software, by the session or whatever, which stays outside of you. What I'm suggesting is SQL-speaking objects. That's the title I gave for it. I'm not saying this is the right title. I'm just using it as an example to show what exactly I'm suggesting instead of using this ORM approach. Instead of breaking objects into parts and having the stupid part and the smart one. So the design should look like this. We should have one big rectangle, which is called the book. And then we have book.rename, and then we give the name. And then this rename method inside the object implements everything using some other object, some other functionality, which belongs to this particular class, to this particular object. And I'll show you the Java example to make it more clear. Let's jump over the slide. So this is the code. This is how I would suggest to implement it technically. Let's say it's a book. I'm using the library of myself, so it's called jkb-jdbc. But it doesn't matter. There are some other libraries which may help you to turn your data source, JDBC data source, into the real SQL query. So in this case, we have a function rename, and we give the title. And then inside this method, the new connection is being established to the database, the new request is built, the parameters are set, and then the update is called, and the actual query goes to the database and gets executed. So there is no third party. There's no other object which stays outside of me. There's nothing inherited. I don't use inheritance here. And there is nothing which can access my private final properties, which are encapsulated. Is it technically clear what this class does, what this object does? Technically, it's clear. So in case of ORM or active record, I want to pay attention to it. So it's not, I'm not suggesting active record. I'm not suggesting repository pattern. I'm not suggesting JPA or Hibernate. All of these things are wrong. This approach is right because it completely encapsulates the functionality of talking to the database. So in this case, we have an object which encapsulates everything, and we can work with this object with enough respect because we know that this is the public interface for us. All we need to do in order to communicate with this object, we just call the rename method, and everything happens inside. Yeah.
Okay, it's clear with JDBC data source. What if you're gonna store or rename this book in, let's say, a usual Java list? How your code should look like? Because on the slide I see book is close relations. It's specifically for data source.
Yeah, it's specifically for data source.
And I would like to store my books not in data source. I would like to store in another storage, like usual list. So it's gonna work. It wouldn't work.
Let's say in files or in the memory.
Just usual list.
Just in list.
List, Java list. It's possible.
So you mean you store books or one book?
One book or many books in one list.
So we need to, again, the question, we want to explain the situation again. So what do we have? We have
my idea is you try to store book somewhere.
I'm storing just one book. It's not a many books. In this case, it's just one book.
Okay, or many books in general.
Okay.
In your example, you have a very close relation with data source. And okay, how this book implementation will looks like if I would like to store this book to another
to the file. Let's say to the file.
To the file or in Java list.
Yeah. Okay. I got the question. Yeah, I got the question. So in this case, definitely the book is coupled with the data source. So the book is designed to be stored. So this book is actually this object book represents a record in the database. So one object represents one record in the database. So that's the representation. So who is this book? This book represents the line in the table by the number ID in the data source, in the specific data source. If you want to represent something else, for example, the book which is in the file, then you create another class, for example, which will implement this functionality differently. Because in this case, the rename method will work differently, and it will differently rename the book in the file. So it's going to be a different class. Yeah, that's my suggestion. It's going to be a different class. Yeah, that's a good name. That book, in that case, that's right. In that case, I would call this book not just a book, but JDBC book, which implements the interface book. And in that interface, I would have the name, the method rename. So of course, that's right. And then I would have the file book, the book in file, or book in memory, or book in the JDBC. Book. If it's a file, for example, then the constructor will be different. The JDBC book will encapsulate data source. If the book is in the file, then this object will encapsulate the file. That's how it's going to be. Yeah, that's the strategy.
Why should we link and why should we couple book implementation to specific storage? Why don't use, let's say, repository like parameter of book constructor? I don't know how repository will implement storage. It's possible to store information in JDBC, I don't know, or in list, in a file. I think it will be more flexible solution. You will have only one book and repository like parameter on a constructor, and you will have a lot of repositories, JDBC repositories.
Yeah, so you're suggesting, so the question is how we can decouple us in general from different data sources. So in the future we may have like different data source, for example, another database, not MySQL but something else. Yeah? So you're suggesting to break this object. I'm saying that the object should encapsulate inside and inside and inside. So like here, we have the object book, which contains the data source inside. So we're not taking it away in order to make it more flexible. Of course, if we take the data source away and turn the book into just storage of data, then it becomes very flexible, because anyone can stuff in the data, anyone can get out the data, so it becomes just a plain, stupid data container, which is of course very flexible. I mean, the flexibility is high, but in the end, we have this with the separation of concerns in two different places. And we lose, in the end, we lose the idea of encapsulation. So we don't encapsulate anymore the functionality, because the functionality of working with the data stays in two different places. So we have some functionality here, which is really minimum, and then a lot of functionality over there, which tells us how we're going to connect to the database, how we're going to store it there, how we can manage the data. So we split the project into two parts. And of course, this part is extremely flexible, but it's not an object anymore, because it doesn't encapsulate its functionality. Because there is no functionality there. We can't put any methods in there. We can't put any methods in there because there's nothing to do in there, because there's no logic in there. We cannot actually make this book smarter except just being a storage of data, except being just a container of some elements. Because if I want to put some functionality in here, I can't, because there's no access for me from here to the database. The database is outside. Only somebody who stays outside of me, this guy who is managing me, only that person, only that piece of code knows how to manage my data. I cannot manage them myself. I cannot connect to the database. I cannot control how it works. I cannot control my transaction, for example. So everything is outside of my control. And that's the problem. So we want to put all these pieces under control inside me. So I want to control everything. And there are a few libraries which may help you to do that. I just listed 3 of the, well, the JDBC is the simple example, the plain simple. You can use just JDBC. It's going to be too verbose probably. It's going to be too much complexity to work directly with JDBC. But there are a few other libraries. The one on the right, I made it myself. This one in the middle is quite popular. So you, for your code in this slide, to implement that, you just find the right library, which will allow you to connect from your Java code to the database, get the data out, and then do something with them. But never let anyone do it outside of you, outside of the object. So everything should happen inside. And not in the inherited, not in the class we inherit, like in active record, and not in some session which stays outside of the object, but everything should be inside the object. It's better for testability. It's better for testability. Why it's better? Because it's these classes, if it implements the interface, it's very easy to mock. If that class would implement the interface, let's say that would going to be called JDBC book, implements the book interface, then this interface we can easily mock, and then everybody who will call rename will immediately hit the mocked version, the mocked method. So that's so easy, so flexible for the testability. That's one thing. Another thing is that the actual SQL request, this update and everything, they will stay inside our objects. Because in this case, in case of the Hibernate, for example, the SQL will inevitably be outside of this and that. We will need to create something else on top of that. Maybe this DAO, maybe something else, where actually the SQL queries will be generated. So again, they will be outside our objects. They will be on the higher level. And eventually, they may be everywhere in the code. The code may be polluted by the SQL queries, and they may be in different places of the application. Not only in the model, for example, if it's an MVC, so they may be in the controller, they may be even in the view, so they may be everywhere. So we have SQL spread out on the entire code eventually. So there are many benefits, and that's what I'm suggesting to do. And that's probably it. That's what I wanted to show, and then I have your questions. Yeah, let's make it more interactive. Yeah, sure. So we want to do again. So we have many books, and say it again. We have many books, and we want to do what?
Change author in every book.
Author on every book. We just go for a loop. That's the first approach, the simple one. We just go through them one by one and change, rename, and we will have many SQL queries. That's right. Yeah. So how to get rid of that?
Yes. Is there any way to make it like with one query?
Yeah, that's possible. In this case, it's a good question. So I'll repeat the question. So we have one book, and in one book we want to, let's say, rename this book. It's easy, we just call one method and the book gets renamed. What about we have the array of books and 100 books, and we want to rename them one by one, and we don't want to make 100 queries. We want to make one big update to the database. In this case, we introduce a new class, a new object, which is called books, for example. And then on this object books, we have a method rename them all, and then we provide the parameters. And then this rename them all method actually inside does the job it has to do. So it creates this massive update query and runs it and does it how it should be done. So every time we implement this functionality specifically for our needs. It's not like some powerful JPA or Hibernate stays outside and provides us all these features, and all we need to do is just compose it a little bit and then runs and then optimizes everything for us, and it does, treating our objects as just data containers which we need to provide in order to help this Hibernate to do the work for us. It's not the case. We implement it ourselves. We always control how it's done. We implement the method which is called rename them all. And we know how it's done inside. We control how the queries go to the database and how we execute them. Yeah. That's how I do it.
I have like one point and one question. So the point is that I don't understand your statement. Maybe you will explore more on the testing, because, for example, if we encapsulate the persistent logic in the repository or DAO or whatever we call it, then it's basically also easy to mock the repository. So I don't understand why do you say that like it's easier to mock the book than to mock the repository. And the next question is like, for example, on my current project we have a system which communicates to one of the REST services fetches some objects from that service and stores, like caches those objects in a persistent storage. And in your case, with your approach, it would require like having two entities of the book, for example, if you fetch the book from the REST API, right? In order to store this book in the persistent storage, you will have to write some mapper or whatever, like to convert the one implementation to the second implementation. And in case if you have just one like implementation, one like stupid book, it's pretty easy to like convert JSON to this stupid book and then store it in database. So what would you suggest in this case?
Okay, first question about the testability. I'll repeat the question probably. So the question is that we have repository pattern or active record, which like here in the diagram, which it encapsulates. This is the object, the inherited one, and this one the main one. But everybody talks to the book, so nobody talks to the inherited one. So the question is, the point is that we can mock this book, and then everybody will just talk to the book. That's true, I agree. Yes, with the active record, definitely the testability problem disappears. So the active record is probably better than the JPA approach. So that's a good point. I totally agree. The second question about what do we do if we get some stupid object, the container, the data container from the RESTful somehow, that we just make a connection somewhere, the JSON comes back to us, we convert this JSON to this stupid container of data, and then we give this stuff to the Hibernate, and Hibernate basically stores into the database. This is definitely easy. It sounds easy. This is how it works. But it's wrong. So I would suggest to do it differently. I would suggest to I would say that I would create the object is coming from the request. We convert it somehow from the JSON. So we not convert it, but we make an object which behaves like a book coming from the RESTful API. So we don't actually fetch first and then stuff this data into an object. We create an object which behaves for us like a book. So it has all the necessary properties of the book. But when we ask that book of the properties, then the requests are made. So it's a little bit vice versa. So instead of being procedural and first of all fetching the data and then making the stupid container of data and placing that data over there, we create an object which if you call that object, then the call goes to the RESTful API. So it's kind of lazy approach, if you understand. That's first thing. And then we have this object which is lazy, which is ready to behave like a book. And then we create, let's say we want to store that stuff. And then in that case, we create these books, for example, the books object. And then we give this books object this new one and say, hey, we have a new book for you. How about you store it? How about you, we're going to add this new book to your collection. And then that one starts to ask for the properties. Who are you asking that book? What's your title? What's your ID? And asking that, the request goes to the RESTful API. We get the data, converted or not converted from JSON, and then they go to the books object. So that's how I would do it. That one, a second. Yeah.
But what about consistency? Suppose that between two REST requests to get different properties of the book, somebody else changes the state of the REST server, and suddenly the data it returns stops being consistent.
So you're saying, okay, I'll repeat the question. So you're saying that first of all, I create an object which knows where to get the data, but it doesn't get the data. Yeah, it just waits for somebody to ask for this information. And then we give this stuff, and then the time starts. Yeah, and then we give this object to the database, and the database starts to ask for this information a bit later, in a few seconds, for example. Yeah. So the question is what to do with this interval between this actual. So we're too late. That's the question. Yeah.
The question is. What if somebody else changes state of the server to which the request goes? For example, the database asks, okay, tell me the author of this book. Mm-hmm. The request goes to the server returns something. Mm-hmm. And sometime, suppose database decides to ask, okay, can you please repeat the author of the same book for some reason? Mm-hmm. Not very logical, perhaps, but it is possible, right? And but by this time, author has been changed.
You're saying, okay, I got it. So you're talking about the situation where we're asking for different pieces of data.
Yeah.
So first of all, we get the title, and then we get the author. And in this, between these requests, we have the inconsistency, for example.
Yes,
Yeah?
exactly.
Yeah, in that case, yeah, that makes sense. In that case, we create an object, which is, that's one approach. Let's say first approach is to implement the method in this JSON book. So we have this RESTful book, let's call it, RESTful book, which knows where to get all the data from RESTful API. And in this RESTful book, we can implement some internal caching. So when somebody is asking for the title, I'm going to go to the RESTful API and get everything and store it locally. So when you come and ask me for the author, I have everything stored inside me. So I cache my data inside. I keep this data in cache, so I go only once to the server. So then this book looks quite consistent. That's one thing. And answering probably another question, let's say I don't want to cache it here, and I just want to avoid people coming back again and again to the server. So in this case, I decorate my book in another book, this RESTful book. I'm gonna decorate it into another book. You know what decorator is. So I'm gonna encapsulate the original book, the RESTful book, and I'm gonna make another book which is called cached book. And when somebody calls that one, it goes to the encapsulated book, gets the data, and caches it here. That's two approaches. So let's get to that question, and then I'll probably get there. Yeah, we have here.
So you said that if you are going to work with list of objects and we are going to update some field, we have to create another object, another class with some methods to work with books, with book, by books. But we still work with book object, and that books became like repository for book. And where is benefit? We still have a repository, but specific for a book.
The difference, that's a good question. The difference is what the question is, again, I'll repeat how I understand it, because repository is the pattern where you just make a class and which inherits from some base class, and you get all the CRUDL methods which you need. Create, delete, update, a list, and everything. So all the functionality which you need to work with the collection of something, collection of books or collection of items, whatever. And in my case, I'm suggesting to create books class, which basically does the same, or close functionality. The difference is that's the conceptual difference. If you treat the right way to treat objects is to treat them as objects, not as literal mapping from tables to Java. So the repository pattern actually tells us that this is not a smart object, this is not a collection of books. This is literally something which is one-to-one attached to the table, which means that we're still talking relations here. We're still talking like relational database. If I create the class books and I don't follow this repository pattern, but I just make it my way, this books class, then it's not going to have all the CRUDL methods. It's not going to have maybe create, it's not going to have delete. It's going to have exactly what I need for my purpose. So all these, if I'd say the big application, I have books, items, users, persons, whatever, and all of them, they will look differently. Because with the repository pattern, it's going to be all the same. They will have create, update, list, whatever, CRUDL, delete. So they will have all the same. So that they will all look like tables for me. Not like objects, not like a bookshelf. But it's going to be like literally a table in the database. Which will make me think like a programmer of relational databases. Not anymore as a developer, in terms of business domain. I'm not going to think anymore about the bookshelf and the group of users. I'm going to think about the table books and table users. And I will think like data instead of objects. So that's what really is bad in general about this repository pattern and the active record, because they all make this object relational mapping literal. They map literally on the table, literally to the object, which is not what objects are for. So that's the big difference. That's probably my answer. Yeah. Yeah, put and get, exactly, put and get, exactly, that's all. But it's going to be always put and get. It's not about Hibernate. No, the Hibernate is not about that. It's like the repository or active record. So it's just a repository where you can put some stuff and get some stuff out of it, which is not what Bookshelf is about. Bookshelf is a structure, is a thing which we want to think about, not just make it blindly and say, okay, the bookshelf is exactly the same as a group of users. They are, in the business domain, they're different. They're not the same. The bookshelf is a bookshelf and the group of users is a group of users. But if you make them, all of them, if you make these two guys inherit the same base class and say, you are the repository and you are the repository, they will look exactly the same. And you will not be able to treat them differently and to continue design them in their own ways. Because the bookshelf may have some methods in the future which will do something with the bookshelf. For example, give me that's going to be the method for the bookshelf. Let's say, give me the most popular author of yourself, which is not the method you're going to add to repository. Because you will think that, okay, it's my just repository. How can I put the method, give me the best author on the repository? But on the bookshelf, you can do that. You can say, hey, bookshelf, give me the most popular book which stays on you. And it says, this is my most popular book. And then the group of users, hey, give me give me the list of users who were active on the last 2 days. And they give it the list of that users. So they are not repositories, they're different things. One thing is a bookshelf, another thing is a room of users. And they have to be named differently, and they shouldn't inherit the same thing, because they are not the same thing. And this inheritance is the abuse of the inheritance idea. So this active record pattern and repository pattern is the abuse of the inheritance. People just using inheritance because it's convenient. They think, okay, we have inheritance, we need some functionality, we don't have this mix-ins or whatever, okay, let's inherit it. That perfectly works. It's great. It works technically, but conceptually it goes to the wrong way. We start thinking about these objects as just containers of data, which are primitive containers of data. And that's what's wrong. Yeah.
All right. So the argument about Hibernate is clear. So like we have, this is called actually a dynamic model.
That's right.
Yeah, and the argument is clear. It's been made several times over the last 10 years. Hibernate is bad. But we all know that Hibernate solves real world problems. Like tons of code has been written with Hibernate and been designed around Hibernate. And actually Spring, as a framework, the most popular one, it forces you into old style like C-like programming model, where functions are processing data structures.
That's right.
That's bad. We all know that. But what I didn't hear in your talk is how to approach this problem, because it's there, with on the legacy projects. So if I have a project and I know there are issues, and I see that this code base is growing, so I'm getting more and more of business logic cramped into those services. What should I do? I can't just throw away Hibernate. It's wrong. I can't just throw away, say, oh, I'm gonna switch to Play.
Yeah, I got it.
The real stuff is happening.
Yeah.
The second issue that I have. So, let me ask you a question. Have you seen real-world Ruby on Rails projects?
Yeah, I have a few of mine.
Okay, cool. So, your argument about active record is not fair to some point. Because I understand that, well, we have inheritance, it's abusive. Okay. So your objects, they end up a bit polluted with some persistence methods, with some infrastructure code that is doing some bindings and etc. But actually, if you look into real-world Rails projects, you will see that its data models are actually live. So they do behave like objects, because there are APIs built on them. Like they have API calls where they put some if statements. If my age is greater than, I don't know, 21, then allowed to sell alcohol, for example. So they are real-life objects. They behave like objects, because objects are about processing state, the internal state which has been encapsulated. So I don't think that argument is pretty clear, because we have an example of Rails. I understand that in Java we suck because we don't have a proper ORM, like a better ORM, but they do, and they have proven to the world that their ORM that is solving, again, the real-world problems is actually working.
Yeah, I got both questions. So I'm going to repeat the question. The first one is, what do we do if we have a project where we have Hibernate and we need to, we have a lot of tons of code, lines of code, which already use Hibernate, and we need to maintain it somehow. We need to continue the development. So what do we do? Can we just throw away Hibernate? Obviously not. Well, in this case, I don't really have a solution. I don't have anything to suggest. I think just get away from that project if you can. Because this stuff, I don't have experience working with a lot of code from Hibernate, but I tried. I would suggest only to, like I said, just start something new or work on. So this is what I'm suggesting for new projects. For the existing one, for the Hibernate, just deal with it, just stay with what you have. So I have nothing else to suggest. If you need like to solve, but for the future, the projects, they get alive and then they die. Then you start new ones, then you start new ones. So eventually, if you start thinking that way, if you start thinking that Hibernate is a bad thing, like you're saying, for 10 years, we know it's a bad thing. But how many projects were started like last year and they were started with Hibernate? A lot. You're saying that we all know Hibernate is bad. We all know this is anemic model, like you said. So how come people for 10 years still use the Hibernate? Why it's not dead? Why the Hibernate is not a dead project? Not because we continue to develop something which was created 10 years ago. No, we start something now, and new developers start something now, even what maybe today, new projects using Hibernate. Why it's happening? Because they basically think that this is the way to go. They don't believe, they don't know maybe that the Hibernate is bad and the anemic model is bad. That's my first answer. So just think for the future. Don't change what you have in the past, but change the future. One second. And about the Ruby on Rails, which they have active record. So active record is, like I said, it's a little bit better than JPA because JPA and Hibernate, they completely tear the project apart and they have anemic the object apart. They have anemic object and then some session outside. The active record in Ruby on Rails, they have it like that. So I have an object and inside I have the functionality from active record. So it works, yes, it does solve real problems, but would be way better if they put this stuff not in the class, not in the object being inherited, but outside, like I showed, like use it as a functionality which they call, and then this call goes to the database. That would be better. We would still be able to solve real problems, but the design would look much better, and our understanding of the code, and we would be way more object-oriented, not that procedural, but more object-oriented. Ruby on Rails is a highly procedural framework, in my opinion. It's all designed on the idea of procedures, not objects. Even though Ruby claims that it's an object language, it's not. It's a lot of mistakes are made there, especially Ruby on Rails. It's kind of, it's not a good network, not a good framework, in my opinion. Even though it solves real problems, of course, like Spring as well. It solves a lot of problems, but I don't think it's a good framework. I think one last question, right? Yeah, you don't need a mic. Just say it. I'll repeat anyway. Yeah. No, it's okay. Go ahead. I got the question. I got it. So what's the benefit? Yeah, so what's the benefit? We have Hibernate, it works, so what's the benefit of using that? The only reason, well, the main big high-level reason is maintainability. We want our code to be more maintainable. Maintainability means cleaner. We need our code to be more understandable. We need our code to be easy to maintain, easy to change, easy to refactor. Object-oriented approach, in general, object-oriented programming, were invented as a replacement of procedural programming because OOP is way more maintainable, more clear, more understandable. It's easy for us, human, to understand. Procedural programming is more complex when it gets bigger. The bigger is the software, the more difficult it is to maintain it if it's procedural. That's why OOP was invented. That's the whole big idea. The way Hibernate works, let's take an extreme example. It makes our code it makes our code procedural because we have the procedure on top, we have the procedure over there, and we have an anemic model, anemic data model over there. So we are managing data like in C language. So it works technically, and maybe it's even sometimes faster than an object approach. But strategically, if you look at the long term, it will be more difficult to maintain and difficult to understand how it works when it gets bigger. So that's my answer. I cannot like show it, I mean, I can probably find some examples and demonstrate how it works in practice, but in general, if you want to be object-oriented, it's going to be in the long run, it will give you a lot of benefits comparing to being procedural. So that's a summary, maybe that's a bottom line. Thank you very much.